So this is our last task and we are about to examine another AVR Studio program. So here is the problem. We are just tasked to examine the stack and the SP register after the execution of the program using single step. So let's now proceed to the video. So at this point, you should already know the drill on how to generate or create a file and establish a file for AVR Studio. So let's adjust some things in here for us to have the convenience when typing the code. So here is our program. I already typed it in for us to conserve time. So let's now try to assemble this code for us to verify if there are errors or no errors within this code. So as you can see, there are no errors and we can now proceed with the build or debugging mode of this code. So now we are in the debugging mode. So let's try to expand the registers. So here is our status registers, the flags. And here's our stack pointer. And we can also monitor the stack pointer as SPL and SPH on this lower right part of the IDE. So let's try to single step this program. On the first LDI instruction, there is no significant changes within the stack pointer or the registers. But there is a high RAM end in the line 1, which means the RAM end is the last address in the SRAM. It is usually 16-bit, which is composed of high and low, but it is breaking down from SPL and SPH. That is why it is 8-bit. So let's take another step. So as you can see, on the first out instruction, the stack pointer has changed its value from 0 to 0800 hex, as well as the SPH. The value has been altered from 0 to 0800 hex. Taking another LDI instruction, but it does not deal any significant changes within the stack pointer. But another out instruction, the stack pointer value has been changed from 0800 hex down to 085F hex, and as well as the SPL from 0 down to 0x5F hex. And as you can see, as we take a look with our register, specifically in R20, the value is changed from 0 to 0x5F hex, meaning that the LDI R20 low RAM end has been loaded to R20. The next consecutive LDI instructions that we are about to take into is just the loading of values specifically from registers R20 to R24. Dragging down to the registers, there would be changes. However, there would be no changes within our stack pointer, SPL, and SPH. And as you can see here, the values that we had loaded to the certain registers are visible, except for R20. So let's take another step. This time, we will use the push instruction to each register. And always remember that when pushing a register, it means that we are getting its value to be stuck on our SP register. And after the first push instruction, the value of the stack pointer has been altered from to 085E hex, while the SPL has been changed to 0x5E hex. And taking another single step, the SPL has been reduced from 5E to 5D hex, as well as the stack pointer. It changes from 085F hex down to 085D hex. Taking another single step, the SPL value has been altered from 5D hex down to 5C hex, and the stack pointer has been altered from 085D hex down to 085C hex. Again, another push to the stack. The value of the SPL has been altered from 5C hex down to 5B hex, and the stack pointer has been altered from 085C hex down to 085B hex. And for the last push, the value of the SPL has been altered from 5 B hex down to 5A hex, and the value of the stack pointer has been altered from 085B hex down to 085A hex. And remember that as we push the stack, we are decrementing the hex value in each stack pointer and the stack pointer register. So let's try to take a look with our registers here as we see the loaded values that we had established. And as you can see, there are the values that we had loaded in the specific registers from R20 to R24. But R20 has been altering values since from the start. So I guess that's it. And that's all for the stack pointer and the stack. And I hope you have learned from this video. Thank you.